Hi, my name is Samir Desai, and in this video, I'm going to teach you how to identify and name an ether. Discovered centuries ago and originally used as a general anesthetic to knock patients out during surgery, ethers have a sweet smell that we regularly see in things like perfumes and oils. The general formula of an ether is ROR. Because ethers are derived from alcohols, the bond to oxygen should look familiar in both. The R is commonly an alkyl group. An alkyl group is a general term to describe the hydrocarbon attached. So it could be a methyl bonded to an oxygen with another, let's say, bigger alkyl group, like propyl. The R could also be an aryl, although this is less common than an alkyl. An aryl is a functional group derived from an aromatic hydrocarbon. So in this case, it could be an oxygen bonded to an alkyl like this, and a simple aryl like phenyl on the right. The phenyl would be a 6-carbon ring with delocalized pi electrons seen in the double bonds that meets the criteria for an aromatic ring. To name an ether using IUPAC nomenclature, identify the shorter chain to use as the prefix and the larger chain as the suffix. Let's reuse the example from the last slide to practice IUPAC naming. The shorter chain would be the CH3, and since ether is an alkoxy alkane, the prefix is meth and oxy, so methoxy. The longer chain would be the C3H7, so the suffix is propane. This gives us an IUPAC name of methoxypropane. We can also name an ether using a common name. The ethers are named as alkyl-alkyl ether. So while the IUPAC name of this example is methoxypropane, the common name is methyl propyl ether. Make sure the alkyls are in alphabetical order and not by increasing length. Let's use this information to identify and name ethers. Remember the formula of an ether is ROR, where R is an alkyl or aryl group. So for each of these molecules, let's target in on the oxygen and identify the two functional groups connected before labeling it as an ether. In A, we see the oxygen, bonded to an alkyl on the left and an alkyl on the right. So yes, this is an ether. Moving on to B, we see an oxygen, although it is double bonded to a carbon. Additionally, the oxygen is not even bonded to two functional groups, so no, this is not an ether. It will help out to draw out C. This molecule has 1, 2, 3, 4 carbons with an oxygen and an alcohol bonded to the end carbon. We'll draw out the alcohol here, and the oxygen must be double bonded, so carbon ends up with 4 bonds. Taking a look at this molecule, there are 2 oxygens. The oxygen with a double bond is not bonded to two functional groups, so that can't be part of the alkoxy alkane. The oxygen here has an alkyl group connected to the left, but a hydrogen on the right, so it is not part of the alkoxy alkane. Therefore, no. Additionally, a carbon bonded both to an oxygen like this and an alcohol would make it a carboxylic acid. Lastly, D. We can see the oxygen bonded on both ends. The left has a phenyl attached, which is one of the most common aryl groups you will see. The right has an alkyl in the form of an ethyl attached. Therefore, yes, this is an ether. Moving on, let's also apply what we learned to make sure we can name ethers using IUPAC and common nomenclature. As a quick refresher, IUPAC naming will be in the form of the smaller alkyl group plus the oxygen and the larger alkane listed at the end. The common nomenclature will be alkyl-alkyl ether, with the alkyls in alphabetical order rather than size. Starting with A, look at each substituent on either side of the oxygen. We see an ethyl group here and an ethyl group here. Since both alkyls are equivalent, the IUPAC name would be eth-oxy-ethane. For the common name, we don't have to worry about alphabetizing. While our first reaction would be to call this ethyl-ethyl ether, we can actually condense this to diethyl ether. Moving on to B, we have 2 identical aryl groups attached. This is called a benzene. The other will be named as a phenoxy substituent to make phenoxybenzene with IUPAC nomenclature. When benzene groups are substituents, the common nomenclature refers to them as phenols. Since we have 2 phenols, this would be diphenyl ether. Lastly, in C, we have an aryl on the left and an alkyl on the right. The aryl is the longer chain, so it will be the suffix using IUPAC nomenclature. Therefore, the suffix is benzene. The shorter methyl group becomes the prefix, so this molecule is methoxybenzene. The common name would either be phenyl methyl ether or methylphenyl ether. Since M comes before P, this would be a methyl phenyl ether. So there we have it. Determining how to identify and name an ether is the first step in understanding the importance of ethers in organic chemistry. Now you should feel comfortable with this concept.